If I take a look at this right-angled triangle, you can see that my right angle is at angle C. If angle A is alpha, then angle B must be 90 degrees minus alpha. If you now add up these three given angles, you will find that the sum of your angles is 180 degrees. Firstly, I'm going to explore the numerical ratio for sine of angle A. Sine of A is going to be sine of alpha, and we know that the numerical ratio for a sine ratio uses the opposite side, which is A, all over the hypotenuse side, which is C. In my next ratio, I'm going to find cos of 90 degrees minus alpha. Cos uses the adjacent side, so that is A all over the hypotenuse, which is C. Have you noticed that the two ratios that I have identified over here are absolutely identical? And so we've discovered that if you have got sine of alpha, you're going to get the same ratio if you use cosine of 90 degrees minus alpha. These are called co-ratios. In other words, cosine is the co-ratio for sine, and the angle theta is the complementary angle for cos's angle of 90 minus alpha. In other words, those two angles add up to 90 degrees. Let's explore this with other ratios. In this example, I'm going to look first of all at tan of angle alpha. If I want to write this as a numerical ratio, that's going to use the opposite side, A, all over the adjacent side, B. Now let's take a look at what I would have got for my numerical ratio if I had had cotan, but from angle B, so that's 90 degrees, minus alpha. Well, the ratio for cotan must be the reciprocal of tan, and if the tan ratio was opposite over adjacent, I must use the adjacent all over the opposite. Once again, you should have noticed that these two ratios are identical. So in other words, I can say that tan of alpha is the same as cot of 90 degrees minus alpha. Cot stands for cotan. So in other words, the cofunctions with complementary angles have the same ratio. And lastly, I'm going to explore using sec and cosec. Sec of alpha uses the numerical ratio of hypotenuse all over the adjacent because it's the reciprocal of cos of alpha. So I write that as C all over B. Cosec of angle B, which is 90 degrees minus alpha, sorry, I need to write that as cosec, must be the reciprocal of sine of 90 degrees minus alpha, as the sine of 90 degrees minus alpha uses the opposite over the hypotenuse. For cosec, I must use the hypotenuse all over the opposite. And once again, you can see that my ratios have come out identical. So if I have identical ratios, then I have got cofunctions. So lastly, sec of alpha is the same as its cofunction cosec of its complementary angle.